Graphing linear equations in slope-intercept form. All right, as always, here's the state standards that we're going to cover. You can take a moment, pause the video, and go through those if you want. Here is the success criteria, so you know if you are successful at the end of the lesson, find the slope of a line, be able to use the slope-intercept form of a linear equation, and be able to solve real-world problems using slopes and y-intercepts. Key vocabulary: slope is the rate of change between any 2 points on a line. It is the measure of the steepness of the line. Rise is your change in y's. Run is your change in x's. Slope-intercept form is a linear equation written in the form y equals mx plus b. I'm pretty sure most of you guys probably saw this at least last year a little bit, but remember slope-intercept form. This is one of the most common ways you see linear equations. All right, a constant function is a linear equation written in the form y equals 0x plus b. So that's just saying there's no slope. So y equals b would be another way to write this. All right, here's different ways that you can see slope. Remember, if it goes up from left to right, we read from left to right. So if your line rises from left to right, that is a positive slope. If your line falls or goes downhill from left to right, okay, that is a negative slope. All right, if there's no slope at all, if it's a horizontal line, just think about the ground outside. If you walk on it and it's completely flat, then that is no slope. That's a zero slope, okay? If it's a vertical line, okay, it is undefined. So you cannot have a vertical line that has a slope because you'd have to divide. You can't divide by 0. We'll get into that a little bit later, but these are the different ways you will see lines, and you will have to determine whether it has a positive, a negative, a 0, or an undefined slope. All right, definition of slope. The slope m of a non-vertical line passing through 2 points is the value of the ratio of the rise, which is the change in y's, to the run, the change in x's. The formula, change in y's over change in x, y2 minus y1 over x2 minus x1. So you may see any of these versions here for slope. All of these are equivalent. So it just depends on what you're given, what's the easiest way to determine what the slope is. All right, again, remember that when it rises from left to right, it's positive. When it falls from left to right, it's negative. All right, again, your slope-intercept form, y equals mx plus b. M is going to be your slope. B represents the y-intercept. So your y-intercept will always be on the y-axis somewhere. And the slope, again, determines how steep it falls and whether it's positive or negative. Finding slopes of lines. All right, example 1. Describe the slope of each line, then find the slope. All right, so the first one, A part here, we can see that it rises from left to right. So this would be a positive slope. It also has a rise of 4 and a run of 6. So we could determine that the slope is going to be 4 over 6, which reduces to 2 over 3. All right, if we wanted to use the points to determine the slope, we could use the formula. Y2 minus Y1, so let's do, okay, this is our X, this is our Y, so let's say minus 2. And then this would be our X and this would be our Y, so minus 2. So this would be our Y2 minus Y1. We have to go in the same order, so X2 minus X1. That gives us negative 4 over negative 6, which is the same as 4 over 6, which is the same as 2 over 3. So you can see that that is going to give you the same thing as the 4 over 6 gave us already. All right, to save some space here, I am going to erase this. Just going to put 2/3. So you can use the rise over run when it's already given, or you have a graph and you can count those off, or you can use the formula as well. All right, B part, you can see that it's going downhill from left to right, so we can determine that that is a negative slope. If we look at the rise over run, it is rising -3, and it is running 2. Remember, it's always the horizontal, it's the vertical over the horizontal. It's the change in y's over the change in x's. All right, same thing, you can use the points to determine the slope as well. But since that's easy to determine, we're going to go on to the next example here. All right, so describe the slope of the line, then find the slope. This one is negative, it's going downhill. So this would have a negative slope. So we can do rise over run if we want. We can go down 2 and over 1, 2, 3, 4, 5. So this would be -2, and this would be 5. So our slope would be -2/5. And again, if you have a graph like this, you can easily determine the slope doing the rise over run. All right, number 2, you can see this one is going uphill. So it's going to have a positive slope. This time, the points are a little further apart, so let's use our formula. Let's call this x and y1, and this x and y2. And so we're going to have -1 minus 3, and then we're going to have -3 minus 3. So that's going to be -4 over -6. 2 negatives make a positive. This becomes 2/3. So that's going to look very similar to the first one we did over here with a slope of 2/3. All right, can you determine this by rise over run? Sure. Let's change this to red so you could go up 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So you can see this would be a rise of 4, a run of 6. 4 over 6 reduces to 2/3, and that gives you the same answer. All right, math praxis and structure. When finding slope, can you label either point as x1, y1 and x2, y2? Explain. And the answer is yes. It doesn't matter which point you choose to be the first point and the second point, as long as you go in the same order for your change in y's over your change in x's. As long as you go in the same order, the points do not matter which one you label as the first point or the second point. All right, writing. When the graph of a line is non-horizontal or vertical, how can you tell whether the graph has a positive or negative slope? All right, so you're always going to look at it from left to right. And if it goes uphill from left to right, it's positive. If it goes downhill from left to right, it is negative. All right, example 2, finding a slope from tables. All right, the points represented by each table lie on a line. So it's telling you that it's linear because it's telling you it lies on a line. How can you find the slope of each line from the table? What is the slope of each line? All right, so if we know these are linear, we know it has a constant rate of change, which means you can choose any 2 points from the table to use the formula to find the slope. All right, so again, let's look at A part, and we're going to say that, let's say 420 is our x1, y1, and let's choose 10, 8. It doesn't matter because it's on a line, so we know that it is linear. This will be our x and y 2. All right, so if we use our formula, we're going to do our change in y's. So we're going to do y2 minus y1, so 8 minus 20, and that's going to be over 10 minus 4. All right, 8 minus 20 is negative 12. 10 minus 4 is 6. So negative 12 over 6 is negative 2. So we can determine the slope for the table for A is negative 2. So it's going to be going downhill from left to right. If you wanted to plot these points, you could verify that the rise over run would be negative 2. All right, B part. Let's choose this point and this point. And again, you can choose any points. It doesn't matter. So let's do M equals 2 minus 2. And then 5 minus 1. 2 minus 2 is 0. 5 minus 1 is 4. 0 over anything is 0. So we can determine that this is a horizontal line. It has a 0 slope. And that should be evident because all the y values are the same. All right. Now, C part, let's choose the first one and the last one. Again, it doesn't matter. If it's a line, we know that there is a constant rate of change between each pair of points. But just to mix it up, we can choose any points we want. So y2 minus y1, let's go 9 minus, and then our y1 is negative 3, so it's going to be minus a negative 3, and then negative 3 minus negative 3. So M equals, accidentally, that should be positive 9 here, not negative. I just had a mark there somehow. All right, so 9 minus negative 3 is actually 9 plus 3. 9 plus 3 is 12. Negative 3 minus negative 3. Negative negative makes this plus. So negative 3 plus 3 is 0. All right, we cannot divide by 0, so this one is undefined. This one does not. That one would be a vertical line, and it would not have a slope. Identifying slopes and y-intercepts. All right, example 3 says find the slope and y-intercept of the graph of each line. All right, so remember our equation y equals mx plus b. This is our slope-intercept form where m is the slope and b is the y-intercept. So if we look at A, we can see that 3 is the slope and negative 4 is the y-intercept. So this one is easy. It's in slope-intercept form. Has a slope of 3 and a y-intercept of negative 4. All right, this one says y equals 6.5. Since there's no x involved, there's no slope here. So that means the slope would be 0. And the y-intercept is 6.5. All right, C part is in standard form. Remember in the last lesson we talked about AX plus BY equals C, standard form. All right, if we want to look at the slope and y-intercept, we can quickly rewrite this into slope-intercept form by solving for y. So if I add 5x to both sides, I'm going to get negative y comes down. I'm going to get 5x minus 2 is already on this side here. Now, slope-intercept form is y equals, not negative y equals. So now we have to divide the whole equation by negative 1. So on the left side, it's going to be y. Now on the right side, it's going to change my signs for both my slope and my y-intercept. Okay, so 5x divided by negative 1 is negative 5x. Negative 2 divided by negative 1 is plus 2. So now that I have it in slope-intercept form, very quickly I can see my slope is negative 5. My y-intercept is 2.